So as a guy, I sometimes get an inkling to do things that I probably shouldn't. And in model railroading, one thing we often do to our track is to solder the rail joints. So for example, with this piece of O-scale track, if you have a couple small pieces like this, and you don't want to have to run as many feeder wires to the track, and you're worried about the rail joiners eventually, losing conductivity because of oxidation and things like that, you might go ahead, pull out the soldering iron and solder those rail joints to help with long-term reliability of the power on your rails. But, the real railroads, they a lot of times now do continuously welded rail. And I'm thinking, well, I've been doing a lot of welding this summer for my son's high school band program. We're building all these really large, elaborate props for their show they're doing at Grand Nationals in November in Indianapolis. And so I was like, welding is pretty fun. I wonder if I can weld track. And doing this in N scale or HO scale is probably going to end up with a puddle of liquefied plastic. But perhaps O scale track is chunky enough to where I could weld the rail together and have my own continuously welded rail. I think the alloy mix is weldable, but we're going to find out. So I have this little Harbor Freight special that was $150. It's actually on sale occasionally for $99. And we've actually bought a couple of these to use at the high school. We have much bigger welders there for doing a lot of the work we're doing. But a lot of times we just have a lot of things to weld at one time. A lot of them are just really small weld joints we're trying to do. And so if you want to have a lot of people work at the same time, you need a lot of welders, and a lot of times you don't need big ones for a lot of projects. So these little guys actually work really well. They are flux welders though, so you don't need any gas like our other ones do. And so that does make them convenient. It is harder to get a good weld with them, and it's a lot messier. Normally we use MIG welders or metal inert gas welders for the work we do. But these little flux welders are really nice and might just be the ticket if I can try to do a couple of really small pieces here. I'll try a small piece to a bigger piece, see how that works. Things are going to get exciting one way or another. Get some protective gear on. Probably I should change my shirt, but we'll roll the dice. All right, here goes nothing. Well, as you might expect, I just melted the track instantaneously. Plastic held up better than I thought it would, though. I'm going to try welding with the rail joiners. Now, one thing with a flux welder, you have to be super fast. Normally we're welding steel. With a MIG welder, it's a lot more forgiving. The flux welder will just melt through stuff like crazy. So you do have to be really fast. So I'll try it again here, see if I can just quickly tack this track together without trying to run an actual welding bead, and see what happens here. Well, it definitely welded. If you try to pull the track off, that rail stays on, and it did melt the plastic a little bit. But you can see I actually melted through the rail pretty good there, just for a 1 second kind of spot weld. So actually, I don't know what I was doing here. I have it's set for like 16 gauge steel or something like that. Let me turn the power way down and see if it'll work better. All right, so anyway, now I am at the lowest power setting on the welder, and we'll try it again and see what happens. 2 quick tacks on the outside of the rail joiner there. Not enough to weld it though. Boy, that track melts so fast. Okay, I got a very, very, very bad weld. Yeah, this apparently is not going to work. If we had steel rail, it would work, but this stuff melts so fast. Man. It's like trying to weld aluminum or something. Just 1 second or 2 is enough to already get the top of the rail like half melted. But it's really weird though, because look, the plastic is actually fine. Let me try the blackened steel rail. One thing with steel welding, the coated steel is a lot easier to weld than the raw steel. It dramatically reduces how quickly you burn through it. So I'm wondering if the black coating on the rail will be enough to slow the rate at which you burn through it. Perhaps it'll make it a little bit easier to weld without just making a hot mess of everything. So why not? Let's try it out. I mean, this track is already trashed, so might as well try it out. So it didn't melt the rail. The rail joiner, if you can see there, it's probably hard to see. The rail joiner just vaporized. Let me try this side here. Yes, it's not melting through. Well, a little bit. So anyway, I think I've answered my question. Is it possible to weld O-scale or smaller track? And the answer is, I mean, technically you can do a really crappy weld on it, but in practice, no. And that's kind of obvious, but it does not really work. The problem was the rail just melted and vaporized trying to weld it. So yeah, just stick to the old soldering iron. You know, welding is not the answer. But anyway, you know, I've been really busy with the volunteer stuff lately and have not had very much time each week to work on these projects. And so I thought it would just be fun to do a quick video and see if it's possible to weld track. So anyway, if you've ever thought about whether you can have continuously welded rail in O-scale or smaller, not soldered but welded, no. Anyway, that's all for now, and thanks for watching.